I'll arrange it here. Okay, the furnace will call it, not the specific heat of this will vary with temperature. Initial temperature is T naught. There's a block of mass M1. The furnace mass is M2. The temperature of this is 10 T naught. A odd block I'm going to place in a furnace whose temperature is T naught and mass of the furnace is T2. Specific heat varies with temperature. There's the initial. So finally, what would be the temperature at equilibrium? Small idea based problems, very, very small. Specific heat, in fact, need not be constant. It varies. Over a range of temperature, it remains constant. So the question is like this. A odd block of mass M and a odd block of mass M specific heat S naught at temperature 10 T naught is dropped into the furnace whose specific heat varies with temperature as S is equal to A plus BT. Find the final temperature at equilibrium. Mass of the block, mass of the furnace, everything is given. How to do this? Specific heat is varying. Who will gain it? So I'll get into the idea like this. Heat gained by furnace is equal to heat lost by block, no? Heat gained by the furnace. Mass M2. What was the initial temp T naught? So M2 into specific heat of this into dt. This should be heat lost by the block. M1 specific heat S naught, final temperature, initial temperature 10 T naught minus T. So what is the specific heat of this? It should be like this. So what is specific heat of it is varying with the temperature. What was the initial temperature? T naught, final temperature T. Try to see the limits. So M1 S naught 10 minus M1 S naught T. Let's integrate this one. So M2 into this will be A dt B T dt. So this will be T naught to T. So this will become M2A T minus T naught M2B T square by 2. Limits T naught to T. So this will be 10 M1 S naught T naught. Let's solve further. M2A, where A and B are constants. A and B are some constants. So this will be M2A minus M2A T naught, M2B T square by 2 minus M2B T naught square by 2, all divided by, sorry, this one, 10 M1 S naught T naught. What we have to do is now here, T is unknown thing, no? So that quadratic equation will come. For that, we have to solve it. So let me simplify further. M2 B T square by 2, M1 S naught plus M2A. This is M2A T. Remaining what all will come? Minus of M2A T naught minus M2B T naught square by 2 minus 10 M1 S naught T naught. Okay, this everything you can call beta, that is a very large term. So this alpha T square beta T minus gamma. Solve for T. Now you do get a problems of these kind of, you have to be extra alert. Getting some furnace specific heat. Sir, you only said specific heat constant. Specific heat can vary with the temperature or a range of temperature. As it is a constant, we are assuming it here. So substituting this, will get an answer. Just I gave an idea that specific heat of substance can vary also like this. Are you getting? So now you have to work out different types of numericals. Don't take the routine, the same thing, that one. So different numericals will be there in the material, in the books. Think on them. Some graph problem I shown. Okay, now suppose say like a it's some people like